Hey everyone, the topic I chose for this chapter to focus on is zero trust. Zero trust is a networking concept that helps protect our organizations, hopefully from attacks and outbreaks. I would say it's something probably relatively new when it comes to networking and firewalling, but it is something that we should try to adhere to and follow and implement, especially with a new network if we're going to implement a new firewall. I'm going to use Microsoft Paint, so buckle up. It could get a little crazy. I'm trying to draw with my finger here. It's the best I got to try to highlight this concept. Let me back this out of here. So I'm going to start with the internet, and I'll just kind of start with how we typically used to view the internet, and unfortunately, some of the organizations, and maybe even your home, is set up this way. So I'll get rid of the little conversation piece there. So the cloud, if you haven't taken a networking class or anything before, typically represents the internet. So I'll just label that there. Okay, so we got the internet there. And then what usually happens is that, get the correct brush here, is that connects down usually to like a cable modem or something. That cable modem probably connects to some sort of router. Routers are typically represented like that. If it's a wireless router, it's got the antenna. And then you could have PCs wirelessly connected there. Sorry, that looks awful. You could have a wired switch, and then PCs or servers or whatever devices coming off of that. And then what we decided, or what we found out, I should say, not decided, is that there's usually the bad guys out here. We'll give them frowny faces because hopefully we catch them and they end up in jail. And they're able to get into our network through the router and into the device. Why? Because we had no protection, we had no separation in between the internet and our internal network. So if you have a PC, a device that's connected directly to the internet, there's no firewall, there's really no protection in place. Luckily, today's modern Linksys, Netgear, you name the brand. I'm trying to think of different brands. They're not rolling off my tongue today. But if you think of any type of router that you probably have at home, maybe you're even getting it from your internet service provider, it has some very simplistic firewall built in. So hopefully what happens is now when the bad guy attacks, it gets stopped and blocked right here, and they're not able to get internal to the network. All right, so what we decided then is we need to have some sort of firewall. So what we've done in most of our corporate networks, and usually there is a modem there, I'm just going to get rid of it, is we have a firewall. This is going to be a brick wall, and this is the fire. I should make it red, but I'm not going to. And then we got the bad guy out here, and then we got our internal network. So the firewall will do our routing for us. So this also operates as a router slash firewall. And that will typically connect us to, in a corporate network, some sort of wired core switch. That wired core switch could connect us to an access point so that we have, it's really hard to draw P's here. We'll call that a P. So we can have wireless devices and wired cell phones connecting, or sorry, wireless cell phones connecting, anything else that needs to be wireless. And then we have our wired devices here. So maybe there's a PC, and maybe I got a laptop, and maybe over here I have a server. All right. So the conventional way of thinking for many years was this zone. So most firewalls operate in a zone type of environment, meaning that we can put things into a zone. We typically had a two-zone type of firewall. The internet and anything out here was bad, and then anything on the internal network was good. Well, there's a problem with that, and maybe you can think of in your head what might be the problem. But the problem with that is if, let's say, this PC over here gets infected with malware. So somehow the bad guy is able to get in, and there's a variety of ways he could get in. Maybe there's a hole in the firewall over port 80, which is HTTP traffic. So he exploits that hole in the firewall because we need to open up port 80 and port 443 so that people on the internal network can go out those ports to get out to the internet because port 80 and 443 are used for the internet. Yeah, well, the bad guys realize that those ports are open and they use those ports to get in. Or he could, phish this user on the PC over here, call him up and say, hey, can you go to my website on the internet and can you download this malware? And now the bad guy got in using a phishing attempt. Modern firewalls should not be using port and protocol anymore. We should not be allowing particular ports through the firewall because the bad guys can figure out which ports are open using port scans and Nmap and things that we'll discuss or have discussed in this class. And instead, what we should use is like an application-based firewall, which can determine which applications are being used, and a whole wide variety of new filtering tools known as the next generation firewall. But I want to get back to the zero trust. Let me erase some of this garbage. So back to this outside bad, inside good. What could happen if this PC got infected is since the inside is good, all the traffic between the various devices is allowed and trusted. And so if this PC got infected, that malware could potentially spread to the entire network. Because as the malware is spreading through the network, it says, oh, this is, on the same good zone, I'm going to allow that traffic through, and it would end up infecting all the other PCs. And that's how we operated for a very long time. Anything on the outside is bad, anything on the inside is good, and if something happened to get infected on the inside, we could be in for a world of hurt. So what zero trust does for us is it says trust no one. We don't want to trust anything at all. Instead, what we want to do is we want to set up multiple zones within our network. So it would look something like this, and maybe we would create a zone, and I'll do these in orange, a zone over here called wireless. So I have my wireless zone over here on the right-hand side. And then over here, maybe this is my server. And so I have a server zone over here. And then maybe coming off of here, I have another switch, and connected to this switch are all of like the faculty laptops. And there'd be a bunch of faculty laptops. And I put all of those into a zone. And I start to zone out my network based on certain criteria. So maybe all students are in a zone, all servers are in a zone, all wireless devices are in a zone, all guest wireless is in a zone, all accounting, all staff. You can decide how you want to break up your network. Now what I've done is I've mitigated a potential outbreak. It can still spread, but not quite as far. So let's pretend the bad guy over here is able to get into the server. Well, if this server gets infected, it can only now spread to other servers. It's not going to get to the faculty laptops because we don't allow communication in between the zones. Communication from that zone to this zone is denied. Communication from the server zone to the faculty laptops is denied. So when again the server gets infected with malware, it does not allow it to spread. So that is the point of zero trust. And what we need to do is, as cyber defense people, is figure out how we should lump our devices or lump our users into various zones. Okay, so I know that's a little messy, and if some of you started watching it at this point, you'd be like, what is going on here? Just real quick run through this slideshow. Zero trust model again is we trust no one. This used to be the old way of doing things. Internet bad, inside of our local network good. We would create those two zones. If something inside of here got infected, unfortunately, it could spread through our entire network. So zero trust establishes those trust boundaries. What we try to do is compartmentalize, create different segments of our internal environment. The idea is to move that security closer to the resources that need to protect, and we would always verify our zones we have created and whether or not they need access to other zones. Because unfortunately, what ends up happening many times with a zero trust model is we start to allow communication in between the zones. Someone here in the campus zone, maybe it's a faculty member, might say, well, I need to access that server over on the wireless zone. And so the firewall administrator comes in and then allows the communication. Well, we just kind of bypass the whole concept of zero trust then if we are allowing communication back and forth. So that firewall is going to define those boundaries and we don't allow traffic between those devices. Now, there could be situations where we do need to allow communication back and forth. So, for example, the campus zone up to the employee applications. So, I'm a faculty member and I'm on campus and I need to access my UMary, which is an application running on a server. What I should do if I'm the firewall administrator is only allow that type of traffic, only allow the traffic from the campus zone to the particular server's IP, and only allow HTTPS if that's the protocol that's being used. I don't need to allow all traffic. I don't need to allow FTP traffic. I don't need to allow gaming traffic, whatever it is. Only allow the traffic that is needed. That can help mitigate a potential outbreak as well. So implementing a zero trust design doesn't require a major overhaul of the existing network. What you can do is you can start configuring the firewall in a listen-only mode. This will give you a picture of the traffic flow. Who is trying to go where on the network? So you can trust everything from the beginning and just kind of sit back and listen. Is anybody from the campus zone going up here? And what types of traffic is it? So you just kind of sit back and you listen for a while. After you've kind of figured out who's going where and who's doing what, then you can define your trust zones. After you've established your trust zones, then what you can do is sort of extend those boundaries if needed. Start to allow the traffic that is going in between the different zones. And then do it based on the relative degree of risk. You know, if you're someone in IT, you probably need to get everywhere. So then you can relax it a little bit. If you're a partner or you're a guest network, you probably don't need a whole lot of, as they would say, lateral access. You only need access to your particular zones. So it's always a work in progress. It's always something that needs to be monitored and something that can be tweaked. But I know this isn't a network administration class, but this is something we should always be thinking of when we implement, when we secure, when we configure, is who needs access to what. It's that principle of least privilege. Only give access to what is needed. I hope after watching this, you have a little bit better understanding of what zero trust is. I know my drawings got a little crazy. Plenty of resources on the internet if you want a more in-depth, more deep dive into this. I encourage you to check that out. But that's all from me for this particular topic. Thanks for watching.